Okay, so I think this is going to work, and I would love to talk just a little bit about some of the notations that we've been using, set builder and interval, and just make sure that we've got a solid sense for how those two work. I've been seeing some issues with inequalities and less than and greater than symbols. So I wanted to make this video just to talk a little bit about those. Okay, so first of all, the two we've got are set builder and interval. And one of the most common domains and ranges is all real numbers. Okay, and all real numbers just means that basically you can plug in anything you want and you can get anything out. So linear functions have a domain and range of all real numbers. Quadratic functions have a domain of all real numbers and a range of, greater than some value or less than some value. And there's lots of other functions that have a domain of all real numbers and range of all real numbers as well. So in set builder notation, the way to write this is with the curly bracket, and then you write the variable x, and this means such that, and then you can write x is an element of the real numbers. Okay. So that would be a good thing to have to jot down in your notes. Again, this is red. I'll just type this in here so that you have it. This is red x such that x is an element of the real numbers. So that little e there just means x is an element of the real numbers. You could also just write it out and say x is an element of the real numbers. That would be fine. And really, in practical uses, you can just write all real numbers like this. If you just write that, that's going to be sufficient to communicate that it is all real numbers. Now, let's see if I can get this to move. In interval notation, we would write negative infinity to infinity, okay? This is red, like I just said. This is red, negative infinity to infinity. That's how we would read it. But it also means all real numbers because it's everything between negative infinity all the way to positive infinity, okay? Of course, if you were doing range, then you would write this as y such that y is an element of the real numbers. Okay, so these are all great ways to write all real numbers. You can write the R, the two lines, the capital R, that means all real numbers. You can write the fancy set builder notation that says y such that y is an element of the reals, or you can just simply write negative infinity to infinity. If I had to make a suggestion for you, I would probably just focus on these because they're the simplest and they're quite clear. So either just writing all real numbers or writing negative infinity to infinity. So while this all real numbers is not technically set builder notation, I think that that would be totally sufficient. But here are some things that you can't write. Okay, so these are what we might call no-nos. Okay, so you do not want to write this. You also not want to write this. This is actually worse. Okay, and so basically we just do not use inequalities with infinity because to say that x is less than infinity is kind of silly because everything is less than infinity. And to say that, negative infinity is less than x is kind of silly because negative infinity by definition is less than every number. So it's kind of redundant to say this. And so we just don't want to. We definitely do not also want to say that x could be equal to negative infinity or positive infinity. It can't. The whole idea of infinity is it's not a number, right? It's just the largest possible idea. It's an idea that we can't really reach. So basically, do not use infinity ever with an inequality. That's a good rule. You just never use infinity with an inequality. And so this brings me to the next point, which is, let's look at this function right here. Okay, let's say, I'm going to change the color back to black here. Let's say that we had this function right here. Okay, and let's just say it looks like that. That's great. So when I'm looking at the domain and range here, I'm thinking for my x values, starting over here and moving, this direction, does the function exist? Well, yeah, the function is going to exist up here because it's going to keep going. And it exists here, and it exists here and here. And so it looks like the domain, which sometimes I just abbreviate as D colon, would be either x such that x is an element of the reals, or I could write negative infinity to infinity. What I cannot write is negative infinity is less than x is less than infinity. No, we do not. That notation just doesn't make sense. Now for the range, it's not all real numbers because there's no function here, 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 right here. There's no function in this whole zone, right? From here all the way up to here. So the lowest value is 2, and it reaches 2, and then it looks like it goes all the way up here to positive infinity. So we may write y such that y is greater than or equal to 2. This is the best way to write it, probably. Y such that y is greater than or equal to 2. In interval notation, our lowest value comes first, and our lowest y value is 2. So we'll write 2, comma, and then that's a bracket. The reason it's a bracket is because it's equal to 2. We want to include 2. And then we'd say comma infinity, parenthesis, because you can include infinity. So we've got to basically put a parenthesis there. So if I were to read this bottom one, I would say everything, or maybe all numbers from 2 to infinity, including 2 itself, or something like that. Okay, now something I can't write is this. I cannot write 2 is less than or equal to y is less than infinity. Again, we do not write less than infinity because it's redundant. Everything is less than infinity. So you do not write less than infinity. You may write 2 is less than or equal to y. That's fine. You can just write that instead of y is greater than 2, but y is greater than 2 is preferable. Okay, you may have got it, but I'm going to give one more example here just to make sure we're feeling solid. So let's say we have this function right here. Let's say that it looks like this and this only. Okay, so that's fine. So let's talk about domain, which we can abbreviate as D colon if we want. These are the x values. So does the function exist over here? No, it doesn't, right? It doesn't exist here, doesn't exist here, here, here. The first time it starts to exist is right after 0. Okay, right here, it looks like there'll be a function value up there if this starts to approach the axis. And so it looks like the lowest value that I can have for my domain is 0, not including 0. So I could write my little curly bracket and write x such that, so it looks like everything past 0 is good. So I would say x is greater than 0. And in interval notation, my first x value is 0, and my last x value is infinity. I don't want to include either of those, so I'll write 0 to infinity. There's a few ways that I could describe this in words. One would be all positive numbers, or all positive real numbers, because from 0 to infinity is just positive numbers. I could also say from 0 to infinity, not including 0. Now, one thing I can't write, again, would be this. I cannot write 0 is less than x is less than infinity. We do not write less than infinity because it's redundant. Everything is less than infinity. I could write just simply 0 is less than x, but again, it is preferable to put the variable first and write x is greater than 0. Now let's look at the range. Okay, so the range of the y values. I start down here at the bottom, start here and see if the function exists, and then move up and see where the function exists. So it doesn't exist anywhere here until I get to 0. Then it looks like it exists from 0 upwards. So again, I can write y such that y is greater than 0, because it's everything greater than 0. Or I can write 0 to infinity, not including either endpoint. But something I can't write is 0 is less than y is less than infinity, because this is redundant. I do not write less than infinity. Okay, so hopefully that's helpful when thinking about domain and range. And I just want to recap that infinity symbols are only used with interval notation. Okay, they are never used with inequalities / set builder notation. Okay, so that's kind of a good reminder. And so we may certainly write negative infinity to infinity, and we may write x is an element of the real numbers, but we may not write negative infinity is less than x is less than infinity. No, we do not mix infinity with inequality signs. Okay, hope this is helpful. See you soon.